question is, doesn't matter in which order we specify those keywords in front of our method. Well, number one, I think that the order of abstract and public, those are basically the method type modifiers. They can be done either way. So this will work too, public abstract. But I don't believe that the return type can be used anywhere else except that right in front of the method. So return type of the method, such as void, has to be specified right before the name of the method. Right. Other keywords are pretty much can be specified in any order. Good question. Thank you very much. So what else I wanted to say about those demonstrations is that this makes it fairly flexible for us to, once we establish our hierarchy of classes, and when I say hierarchy of classes, it's really that we have a superclass like this, right? And we add some functionality to it, which may include both data attributes and constructors and also methods, and this is all fine. All right, and those special types of methods, which we call abstract, which have no definition at the superclass level. However, of course, any class that extends, in other words, re-implements everything that base shape interface or wants to have, our obligation is to add draw method, which is being declared abstract. And also, when we have something like this, I think it's extremely useful to have an override, because after all, it's still an exact override of the method which was only declared in the base shape, but now we're trying to define it. So both rectangle and circle, when we define these methods, we should be saying override, because you probably don't want to miss the boat simply because you misspell something. You want to be sure that the base class or superclass does contain this specific method, which takes, in this case, takes no parameters and has a return type of void, right? So so these are a few of these observations about the code, and this is how the way the code looks like. It's really nothing difficult, except that also notice that there is a way to delegate part of the constructor work to the superclass. The only limitation on this is that if we know that the base shape captures one of the points that we need inside our rectangle, then of course we pass x and y as the first point parameters there. But remember that the call to the constructor by the rules of the language using the super keyword must be the first executable line of code in your constructor, right? So you cannot say x2 equals x2, y2 equals y2, and then make a call to a superclass constructor. That's illegal, and if we try building this, let's see what the error message says. Their error message says, error, constructor base shape in class base shape cannot be applied to given types. So anyway, it also complains about this, because there's another layer of complaint, because base shape makes those attributes protected, and therefore we need to because it has a specific constructor, the default constructor is gone. So this is the error message that you get. It basically says constructor base shape. But if you click on this, right, it points you to the constructor, and then it basically tells you in the second error message that hopefully here, right? So it says the call to superclass constructor must be first statement in constructor. So you get all this information, and all you have to remember is that you need to do this, right? Anytime you want to talk to the superclass constructor, this must be the first statement in your code. So that's just a simple requirement by the language. Also, comparing this with C++, in C++ we have something that's called constructor initializer list, which allows you to write code somewhere in this area right here. But in Java, instead of creating another grammar construct, what has to happen is just it needs to be the first statement if you want to invoke superclass constructor. Okay, so these are the highlights and demos for our inheritance. So let's save everything and make sure that it's runnable and that we leave this little demo in good shape. So it's probably worth posting alongside with our recordings today. But let's now switch to, if we navigate to our outline, our official presentation on inheritance, which is, by the way, chapter 8 in the book. So if we go to this presentation, this is a presentation on inheritance. So let's just visit topics of this inheritance presentation, and we begin with some basic definition. So this is sort of like round 2 of our conversation today. We did some demos. I show you the code. It really is not that difficult to write any of that code, and everything came out just right. We were able to talk to our objects once they were made part of array list, and this was all successful. But let's reiterate back to the basics and just say the following, is that at design time, when we talk about a representation of our classes in some sort of in the form of a design diagram, we can use UML notation, and UML notation requires us to specify the class name at the top. It requires us to specify a section with data attributes and a list of methods. These are things that we can specify. And in this particular demonstration out of the book, the parent class or base class is referred to as superclass. So in many instances, you can say base, superclass, parent class. People will probably recognize what you're trying to refer to. It's basically the class on top of the hierarchy of classes. But Java predominantly sticks with the superclass and subclass terminology, whereas C++ typically adheres to base and derived class type of terminology. But superclass and subclass are still okay to use. Now, so here there's one class, there's another class. This is a demo from the graphics library, the library which is managing graphical user interface in Java, the Swing library. And so inheritance between classes, something that we used in the code that looks like an extends keyword, something that is being specified by the extends keyword, connects two classes, says that there is actually a relationship between them. It's an inheritance relationship. On these diagrams, typically you see an arrow with the hollow triangle head, and this says that this class extends from this class. And why I know this, because on diagrams, if you recall, you always vocalize those relationships in the direction of the arrow. So I say product frame class extends JFrame class, or in other words, this subclass inherits from the superclass. So these are all things that we can vocalize. Anything that's made public in the class is instantly declared as public interface of that class. So we need to have a bit of a conversation about that. So another demonstration from the book, Swing Forms Hierarchy. This is again graphical user interface library, and this is the example that exists there. So it tells us the following. We can go and say that there's a class here named JFrame, and this class inherits from a frame, which inherits from a window, which inherits from a container, which inherits from the component, and component inherits from object. So what it all means is that you can, instead of just saying there could be one parent class like base shape and one subclass which is rectangle or circle, over here we're saying that sometimes it's useful to keep extending our objects or class definitions, creating this inheritance relationship which has multiple levels of inheritance. For instance, in Java, all classes that we create implicitly derive from an object class. There is a class named object, and so is the Swing component. So the Swing, Swing is the Java graphical user interface library. Its package name is Swing, and so in that library of classes, every component that exists there is named component, and of course it implicitly inherits from the object Java class. Then some of the components are to serve as containers of gadgets, and there are other classes that derive from there. And for instance, if we're talking about a specific window, a very typical situation is that the window is instantiated as JFrame, instance of a JFrame class, which on this diagram it shows that it's not a standalone class. It actually extends from the frame, which in its own turn extends from window, which and so forth and so forth. So this is just an example of hierarchy of forms and controls inside Swing. So it's in our book. So information about the object class. There is object class in Java. We can we can even experiment with that, which may looks a little strange, but I could say something like this: object, which is part of the language, obj here, equals new string, right? New string, and I could do something like that, strangely, right? But the object class is the top of Java hierarchy. Every time you have a class in Java, you have this specific class at the top of any class that you actually create in Java. So as you can see, you can actually have a reference of this type, and you can create a string, because of course string as an object derives from object. All right, so here's the information about this. Every object inherits some methods from object, and two of the most common methods is toString, okay, and equals. So equals actually compares memory locations by default. Compares the memory locations of the two objects, and the equals method of the object class allows you to compare objects, to define whether to find out whether they are the same or different. And toString method is also a method that simply returns the name of the class and reference of that object. For example, in our demo, when we said draw, remember it's like a mock-up draw of methods here, but we could say, so this is my circle class and its method draw, which of course was declared as abstract by the base shape, but then this is the concrete implementation or an override. So here I could say if I wanted to call or convert my shape to a string, I could do this by simply saying toString, because toString method does exist. It may look a little confusing, but this is a call to the implementation of toString provided by the object class. So I cannot really say something like this, because this is a syntax to refer to static method calls, right? So if toString was a static method, then I could use object to make a call. Instead, here I will have to use this if I wanted to specify which object to convert to string. So let's add this and just see how it looks like when we convert it to string, except that I can also insert another space here to keep everything separate. So this is what I would like to add to my rectangle class as well, right? So when I try to visualize it, I will also say, okay, let's convert it to string. Okay, so plus that, and I need another plus in front of it, so everything gets converted to a string. And if I run this with my modification, as I told you, what default implementation of the object class toString method does is basically takes let me just increase the size of it a little bit. Right? What it does, it takes the name of the class and concatenates it with the internal Java Virtual Machine memory address, and also adds an @ in between. Basically says this is a rectangle located at this address, and this is the default implementation of toString. But what I can do is that I can go to my base shape and redefine it.